Hello ladies, gents, and everyones. It is Thursday, April 28th, and we're here to talk about this week's space and astronomy news. The trusty old Hubble Space Telescope passed a big milestone this week, its 32nd anniversary. That's right, the Hubble was launched on April 24th, 1990. The telescope was officially planned to last 10 years and hopefully 15, and while it has faced some challenges in keeping itself going, including an extended downtime over a month last summer for troubleshooting, it's still here and it is still going. It's almost as old as I am. In honor of the milestone, NASA released this image, which highlights Hubble's unique abilities in observing invisible and ultraviolet wavelengths. This is the Hickson Compact Group 40. Catchy name, that. And it is a group of 5 interacting galaxies, 3 spiral galaxies, an elliptical galaxy, and a lenticular galaxy. And all 5 of these galaxies occupy a space less than half as wide as the Milky Way. In another billion years or so, all of these galaxies will have merged into one elliptical galaxy, but for now, we get to enjoy the sight of one of the most densely packed compact galaxy groups. And of course, Hubble's successor is the amazing James Webb Space Telescope. I gave you the good news a couple weeks ago that the last instrument has finally reached its frigid operating temperature, but does that mean the entire telescope is at temperature? Not quite. While all of the instruments are cooled, the mirrors themselves have not completed cooling. Now, the mirrors don't need to be quite as cold as the instruments. So the near-infrared instruments need 37 kelvins and MIRI mid-infrared instrument needs 7 kelvins. But the mirrors need to be less than about 50 kelvins in order to prevent emitting some mid-infrared light that could be detected by MIRI. Now, this cooling process takes such a long time because the mirrors are made of beryllium, which just takes a really long time to change temperature. But the secondary mirror and 14 of the 18 primary mirror segments have cooled, so there's only 4 primary mirror segments left to go, and they only have about half to 2 kelvins to cool. So we are almost there. The 7th and final stage of telescope alignment is still ongoing with MIRI, and science operations are on track to start as expected in June. And while we still don't know exactly which target is going to be the lucky very first target, we do know there's a lot of amazing targets that have been selected to be looked at in the first 6 months of operations. DNA, or deoxyribonucleic acid, is found in all known organisms and is basically a very crucial part of life. The building blocks of DNA are nucleotides, which are famously abbreviated A, C, G, and T for adenine, cytosine, guanine, and thymine, I think. Similarly, RNA, which just gets rid of the deoxy part, so it's just ribonucleic acid, uses 3 of those nucleotides, G, A, and C, but also adds a U for uracil. Okay, so I'm not a talking strand of DNA and I don't have any dinosaurs to show you, but hopefully that gave you an idea. As important as these molecules are, their exact origin is still unknown, but several studies have previously found that in laboratory conditions similar to those found in outer space, they can actually form all 5 of these nucleotides. And in fact, 3 of these nucleotides, G, A, and U, have been previously detected in meteorite fragments. Well, a new study published this week in Nature Communications used extremely sensitive state-of-the-art analytical techniques to determine that there are in fact T and C nucleotides in meteorites. This makes it even more plausible that these very important building blocks of life might have formed in outer space and been delivered to a primordial Earth via impacts. So the weather finally cooperated with us this week, allowing the Axiom 1 mission to safely return home and splash down on Monday. The crew got to spend an extra 7 days beyond their planned 10-day mission on board the International Space Station. The return of Axiom 1 and Dragon Endeavour cleared the way for the launch of NASA's Crew-4 mission. And Crew-4 launched very early on Wednesday morning from Kennedy Space Center in Florida, carrying on board 3 NASA astronauts and an ESA astronaut. And one of these NASA astronauts, Jessica Watson, is setting history as the first Black woman to be on an extended mission on the ISS. This was the first flight for the newest Dragon capsule and probably the last ever Dragon capsule. And Dragon Freedom docked with the International Space Station late on Wednesday night, and the crew was able to join Expedition 67. Now that Crew-4 has successfully arrived, Crew-3 is expected to depart the station next week. Beta Pictoris is a young and nearby A-type star, which is probably best known for its directly imaged planetary system. Or else I'm biased because I'm an exoplanet scientist. But I mean, just look at this video of Beta Pic B actually orbiting its star. Very cool. Beta Pic C is also the closest ever exoplanet to be directly imaged next to its star. But Beta Pictoris doesn't just have planets. As a very young system, it also has a visible debris disk as well as planetesimal belts. And as we'll talk about today, Comets. Yes, that's right, exocomets. Now, evidence of these exocomets in the Beta Pictoris system has been known since the 80s, and we've seen transits of these exocomets using tests back in 2019. So the existence of the comets themselves is not the news. But a new study published today in Scientific Reports was able to measure the size distribution of these exocomets. They had a whopping 30 comet transits from test data, and they were able to use these to measure the relative occurrence rates of different comet sizes. And it turns out that the proportionality of that distribution is the same as comets in our solar system. And these distributions are consistent with what scientists expect from fragmentation and collisions during planetary formation in young systems. Being able to go from n=1 to n=2 is a huge step forward in our ability to understand these processes that shape planetary systems. I hope you guys aren't sick of hearing about the Mars helicopter, because I have some really cool news. So last week we celebrated the 1-year anniversary of Ingenuity and its 25 flights. Well, flights 26 and 27 are now in the books as well. Now, the flights themselves weren't particularly notable. Side note, how crazy is it that flying a helicopter on another planet is now kind of considered routine? But NASA released images from the Flight 26 that definitely are. This looks like footage from like a UFO crash in like a budget sci-fi film. And it is. I mean, it is the wreckage of an alien landing craft, ours. This is actually the debris field from the landing of Perseverance and Ingenuity on Mars last February. You can see the back shell and the parachute, as well as small bits of debris. This is not just really cool to look at, it actually also gives NASA data about the landing that can be used for future landings. And it's really cool to look at. Well, that's all I have for you this week. Thank you so much for watching, and I will see you again next week. Have a good one. Bye!